our third lecture of our chapter number 3, which is the design of industrial building. Okay, so in the last lecture, we have to discuss about there is two types of examples are there. First one, we have to find out dead load, wind load, and live load. Okay, which is acting on an industrial building. And in the second type of example, we have to discuss that there is two types are there. First, when the load is directly given, and in the second type there is a find out a dead load, live load, and wind load, and after the help of these load combinations we have to find out total load on a per lane, and after that we have to design for per lane. Okay, so students, now in today's session we have to solve our example number 1, which is how much loads which is acting on any industrial buildings like shade. Okay, so first of all in today's session we have to find out dead load, live load, and wind load which is acting per panel point, and after that I will give you one example for your homework. Okay, so now let us start our example number 1. So students, the question is determine dead load, live load, and wind load per panel point. It means you have to find out dead load, live load, and wind load per panel point. It means which per lane takes how much loads. For the roof truss for the workshop shed constructed at Ahmedabad, this location is useful to find out basic wind speed for the following data. So the data is span of truss. It means this is the value of L, which is equal to 15 meter. Spacing of truss is 4 meter. It means in horizontal direction the spacing between two columns are 4 meter. Next is rise of truss is 3 meter. It means the distance between main tie and the ridge point is 3 meter. Height of truss above ground level, it means the height of column is 20 meter. In roofing material we have to use ACC sheet having the self weight of 150 Newton per meter square. Next is assume a self weight of purlin and other fixture as 120 Newton per meter square per plan area. Total number of panel is 8. It means 4 panel on left side and 4 panel on right side. Opening of wall area. This opening of wall area is useful to find out CPI, internal pressure coefficient. Probable life of period is 25 year. Terrain category 3 and class A, and topography is equal to plane horizontal ground less than 3 degree. Okay, so this last two data is useful to find out wind load calculation. Okay, so students, as per data given, let us start our so you can see that there is 8 panel over here. Then this is panel number 1, 2, 3, and 4. 4 panel on left side and 4 panel on right side, in which we have to calculate only for half side. Okay, another half side is calculated as per our calculation of half side. Okay, so you can see that this is our eve purlin, or it is called as end panel point. This all 3 point is called as intermediate panel point, and this is your end panel point. Okay, you can see that one panel point over here, so it is at this point, and one panel point is at this point. There is, you can see that there is two panel point over here, one for left side and one for right side. And as per data given, our span of the truss, it is 15 meter. So you can see that this length is 15 meter. Height of column from ground level is 20 meter. Rise is 3 meter. So now, as discussed earlier, that our first step is to find out preliminary dimensions, and in preliminary dimensions our first step is pitch. So what is the equation of pitch? Pitch means rise divided by span. Now what is the value of rise? It is 3 meter divided by 15 meter, so it is 1 by 5. Next is angle of roof truss. It means we have to make alpha with horizontal plane. Then the equation of tan alpha is rise divided by L by 2. So our value of rise is 3 meter and L by 2 it means 7.5. So we will get our alpha 21.80 degree. Now third preliminary dimensions is this length. This length is length of principal rafter, and this length will be find out with the help of Pythagoras. So if we have this value is 3 meter and this value is 7.5 meter, then the length of principal rafter is under root 3 square plus 7.5 square, and it is 8.07 meter. Now, fourth is half plan area. Now, as discussed earlier, this fourth and fifth portion is very most important. Half means we have to consider only this half portion. Plan, it means we have to see it from the top of the view, and whenever we have to show from the top of the view we have to show only this length. It means only 7.5 meter length, so it is 7.5 into spacing of roof truss, and it is the column distance between column in horizontal direction, and it is 7.5 into 4, which will give our answer 30 meter square. Next is half slope area. As name given as half means we have to consider only this portion. Slope, it means we have to show a slope portion, and what is the value of slope? It is equal to length of principal rafter. Okay, so it is 8.07 into 4 because it is into spacing of roof truss, and we will get our answer 32.28 meter square. Okay, so students, this is our basic dimensions. Now we have to find out dead load, and in dead load, as discussed earlier in the last lecture, that there is four loads are there. First one is sulfate of roofing material, second is sulfate of purlin, third one is sulfate of roof truss, and at last it is sulfate of wind bracing. Okay, so in the question it is clearly given that we have to assume that the sulfate of roofing material is 150 newton per meter square, and this sulfate of roofing material is considered as for slope area. Okay, so 150 is in newton per meter square, but if we have to find out load, load means force, so what is the unit of load? It is newton. So we have to convert newton per meter square to newton by multiplying some area, and that area is half slope area or half plan area, which we have to discuss in the last lecture. So in the last lecture we will discuss that whenever we have to calculate the sulfate of roofing material, then we have to consider half slope area, and for other three loads, which is sulfate of purlin, roof truss and wind bracing, we have to consider half plan area. Okay, so it is 150 into 32.28, so we will get our answer 4846.5 newton. Second is weight of purlin. Now you can see that the sulfate of purlin and other fixture is given as 120 newton per meter square. So it is 120 into 30 because we have to consider half plan area. So our total load is 3600 Newton. Third is sulfate of roof material, and the equation is 10 into span by 3 plus 5. Now span means L. So what is the value of L? It is 15 meter. So if we are putting this 15 meter into this equation, so we will get our answer 100 Newton per meter square. Now we have to convert Newton per meter square to Newton by multiplying half plan area. So it is 3000 Newton. Okay. And fourth dead load, it is weight of wind bracing, and the weight of wind bracing is assumed in the range of 12 to 13 Newton per meter square. Now there is no any clarification regarding self-weight of roof bracing, then you have to assume that it is 12 Newton per meter square in this example. So it is 12 Newton per meter square and we have to multiply it with 30. So it is 360 Newton. Now, what is the total dead load? So the total dead load is the summation of all these four values. So the summation of all these four values will be 11,806.5 Newton. Okay. Now this dead load is acting on half portion. So we have to distribute this 11,000 into this panel point. Okay, now you can see that this panel point is half panel point. This is full because half of the load is coming from left side and half of the load is coming from right side. It means this is your intermediate panel point and this 2 is also your intermediate panel point. So this panel point takes full load and these two panel point is called as end panel point which takes half load. So total number of panel point is 0.5 plus 1 plus 1 plus 1 plus 0.5. It means total 4 panel points are there, 3 full and 2 half. Okay, so we have to distribute this 11,806.5 Newton into 4 panel points. So you can see that dead load per panel point is 11,806.5 divided by 4, which is 2951.6. It means these three panel point takes 2951.6 while these two takes half of the full panel point. Okay. So students, this is the calculation of dead load. Now similar calculation of this type is same for live load and dead load and wind load. Okay. So now let us start. Our second load is live load. And on live load, first is live load on purlin. And on live load on purlin, there is two cases are there. First is when alpha greater than 10 degree and second is alpha less than 10 degree. So you can see that your alpha is equal to 21.8 degree in this example. It means in this example, our alpha is greater than 10 degree. Okay. So for alpha greater than 10 degree, our equation of live load on purlin is 750 minus 20 into alpha minus 10. So after putting all this value, we will get our answer 514 Newton per meter square. Now you have to check that your answer is greater than 400 or not. If your answer is less than 400, then you have to consider 400 is your minimum load. But if your answer is greater than 400, then you have to consider that answer for the calculation of live load on roof truss. Okay. Now live load on roof truss is 2 by 3rd of live load on purlin. So it is 2 by 3 of 514, which will give us the answer of 342.67 Newton per meter square. Now this load is also considered as the half plan area. So 342.67 into 30. So we will get our answer 10280 Newton. It means on this half side portion, 10,280 Newton live load is there. Now we have to distribute this 10,280 Newton into 4 panel points because there is 3 full panel point and 2 half panel points. Okay, so the live load per panel point is 10,280 divided by 4. So you will get your answer 2,570 Newton. And so this 2,570 is the value of full panel point. Now what is the value of half panel point? So it is 2570 divided by 2. So you will get your answer 1285 Newton. Okay, so students, this is the calculation of live load. Now we are moving further to our last load, which is wind load calculations. So for wind load calculations, first of all, you have to find out Vz is equal to Vb K1 K2 K3. So this Vb K1 K2 and K3 is the revision of your last semester, in which Vb is basic wind speed. So as per appendix A, you have to find out the value of Vb is 39 meter per second for location Ahmedabad. If the design life is given as 25 years and the basic wind speed is 39, so your value of K1 is 0.92. Now K2 is terrain height category. So students, in these examples, category 3 is given, class A is also given. So generally there are three different values, 10, 15 and 20. But there is no any columns divided over here. So we have to find out the value of 20 meter, which is for maximum value. Okay, so you can see that on table number 2, which is given on page number 12, for category 3 class A and for height 20 meter, your value of K2 is 1.01. Now the next term is K3. K3 means topography factor. Now the K3 value is also given on page number 12. So it is already discussed that when the theta is less than 3 degree, then your value of K3 is 1. So after finding out all this value, your value of Vz is 36.23 meter per second. Okay. Now our step number 2 is design wind pressure. So the equation of design wind pressure is zero point 0.6 into Vz square. This equation is also given on page number 12 on the right side bottom. So students, after putting all this value, we will get our answer 787.5 Newton per meter square. Now our last step, which is the most important step, which is design wind force. So the equation of design wind force is given on page number 13. So the equation is CPE minus CPI into A into PZ. Now what is AE? So if your shade is like this and wind load is acting on this side, okay, or your wind load is acting from this side, so wind is generally acting on a slope area. Okay, wind is never acting like this. If wind is acting like this, then you have to consider for plan area, but always wind is coming from horizontal direction and it act on the slope area. So our A means half slope area. Now Pz, which is already calculated in our step number 2. Now what is CPE? CPE means external pressure coefficient, and the value of external pressure coefficient will be find out from page number 16. So you all the students are moved to page number 16, in which you can see that there is three cases are there. So which cases are preferable in this example? So first of all these cases will be depend on h by w ratio. Now what is h? H means 20 meter in this example, and w means 15 meter in this example. So our 20 by 15, which will give us answer of 1.33. Now 1.33 means our second case, because for second case our h by b value is in the range of 0.5. 1 by 2 means 0.5 to 3 by 2 means 1.5. Okay, so we have to refer this second case. Now you can see that for alpha 21.8 degree, so you can see that over here this is roof angle. So 21.8 is in the range is in the between 20 to 30 degree. Now you have to find out four values: EF, GH, EG and FH. So first is EF. So you can see that for 20 degree your value is 0.7, and for 30 degree your value is minus 0.2. So with increasing in the angle, your value is also increased from negative to positive. So you have to find out for value of 21.8 with the help of linear interpolation, and you will get your answer minus 0.61. Second is GH. So you can see that the value for 20 degree it is minus 0.5. Your value of 30 degree is also minus 0.5. It means if your angle is increased in the range of 20 to 30, there is no change in the value of GH. So it is minus 0.5. Similarly for EG, you can see that it is minus 0.8, and for FH, your value will be differ with the help of increasing in the angle. So these are the four values, but the maximum value is minus 0.8. Minus sign consider for suction. Okay, so we have to take a maximum value of external pressure coefficient, which is minus 0.8. Now we are moving further to the internal pressure coefficient. So you can see that on page number 27, internal pressure coefficients close numbers are there, in which close number 6.2.3.1 says that if your wall opening not more than 5 percentage, it means if your wall opening is less than 5 percentage, then your internal pressure coefficient is plus or minus 0.2. Okay, now what is the value of internal pressure coefficient for greater than 5 degree? So this clause is given on page number 36. So you all the students are moved to page number 36, in which there is a clause number 6.2.3.2 says that if your wall opening is in the range of 5 to 20 degree, then your internal pressure coefficient is plus or minus 0.5. And if your wall opening is larger than 20 degree or 20 percentage, then your internal pressure coefficient is plus or minus 0.7. Okay, but in this example our wall opening is 10 percentage, so for 10 percentage our internal pressure coefficient is plus or minus 0.5. Now plus 0.5 and minus 0.5, for which value our force will be maximum. So you can see that our force will be maximum for minus value, because the bracket portion is maximum for minus value. If we are putting the plus 0.5 in this equation, then it is minus 0.3. Okay, so minus 0.8 minus 0.5, Now, as discussed earlier, that our AE means half slope area. So it is 32.31 or it is 32.28 into BZ, which is calculated in our step number 2. So our final answer is 33,077.36 Newton. Now this load, which will be distributed on 4 panel points, so these calculations is remain same as dead load and live load. Okay, so students, this is the end of our example number 1, in which we have to find out dead load, live load and wind load calculations per panel point. Now one exercise is for you for the homework. Okay, so if you have any doubt, then please contact me. This is the similar examples like our example number 1. Okay, so this is the end of our today's session. Thank you.